Hey, let's start by logging into Clever. All right, for your warm up today, what is something that you'll never do or think about the same after surviving this pandemic? For me, I don't know, high fives and shaking hands or generally like touching people that I don't know is going to be hard for me to get over that. So, welcome to week 3. This is lesson 5. We are continuing to push in understanding what polarity is, and particularly water as an incredible polar molecule. So, some reminders for you as always, please check assignments. I do my grading on usually the Sunday and Monday, and you'll see grades being updated on Google Classroom and then on Infinite Campus. So, if something seems off, just make sure you're checking there and communicating with me on what you think is going on. With Edpuzzles, remember anything with a number sign in front is required for you to do. Last week, and actually this week, there is an optional Edpuzzle that's up there for your notes that you're going to be taking, if that's how you prefer or do best in learning. But it is not required, only the ones with numbers on it. So like for this week, we have our week preview. Try to attend the live lessons. I really do recommend that because it is a great way for you to interact and for me to kind of see in live time where shortcomings or issues are coming up. And as always, this week we have another Check for Understanding quiz. Please use your resources, use the notes that you take, use the assignments that you do to support you in doing other assignments, okay? Let's remember our class expectations, because we are getting ever closer to being back together in person. And these expectations hold true in our virtual space or in our in-person school space. So please make sure that you're putting these to practice. Remember, I really am encouraging you to start strong. We are only 3 weeks in, so we're not at a point where the amount of work should be like completely overwhelming and demoralizing, but we're approaching that kind of tipping point. So don't let yourself get too far behind. You can probably sit down and get all of the work done that has been assigned thus far in maybe an hour or 2 hour period. So just really, really try to start off the semester strong. I'm proud of you for being here. So this week's assignments, again, we're talking about water structure and how it's a polar molecule. And then what we're really starting to think about is how that structure and its polarity affects the properties of water that make it such a vital and interesting molecule on Earth. So there's 4 assignments this week, one of which I hope you've already done, which is the Edpuzzle preview. You have some Cornell notes again that are going to go with the water properties. And then in our second lesson this week, we're going to go back through those properties of water a little bit in more detail. Preparing you for a Check for Understanding quiz, and then this water cycle introduction activity that is going to pull back to things that we know about the water cycle and introduce us to things that could be affecting the water cycle and the water that we use daily. So thank you guys for being here. Let's get to work. Okay, so what we're going to start with to kind of review and prime our memory. Over here on the left, what you should notice is 4 different shapes with some lines drawn through them. Those lines represents the lines of symmetry that each of these shapes has. So this box at the top, it has 4 lines of symmetry. 1, 2, 3, and 4. This arrow, it has 2 lines of symmetry. The triangle has 3, the star has 5, okay? All I want you to do is over here I'm going to choose 3 shapes and tell me how many lines of symmetry each of those shapes would have. All right, so the big thing with symmetry is to understand that if it does not have perfect symmetry, that means it is not symmetrical and is a polar molecule. If it does have symmetry to it, like these 2 examples down here, that means we have a nonpolar molecule. So let's turn that attention to 2 examples here. Tell me if each element or each molecule is symmetric or not, and then if it is polar or not. Remembering that if it is not symmetric, it's polar. If it is symmetric, it's nonpolar. I know it's confusing. All right, so this first example, if we were to draw a symmetry line down the middle, it is not symmetric because what's on both sides is different. So this would be a polar molecule. Over here, if we draw these lines of symmetry, we would notice that there is a balance. They are the same on all sides. So this is symmetric and nonpolar. Now, the water or the molecule we're focusing on here. Do we think that there are any lines of symmetry? So we should recognize that there are some lines of symmetry. it is, and we should be able to hopefully recognize if it is symmetric or not. So it is not symmetric. We notice that this line of symmetry does have the same. On this line here, it is not the same. So is this a polar or a nonpolar molecule? It is a polar molecule. That is that much we know. Now let's think about in which directions are the electrons pulled more. So in a polar molecule, that means that there's an unequal pull of electrons. Electrons are negatively charged, and that pull is determined by the electronegativity. The electronegativity of oxygen is 3.5. The electronegativity of both of these hydrogens is 2.1. So in which directions are our electrons being pulled? They're being pulled towards the oxygen because it has that bigger electronegativity. Because those electrons, again, that are negatively charged, they're being pulled more towards the oxygen. Where will the negative charge be? And where will the positive charge be? The partial negative charge will be on our water molecule, will be on the oxygen side because it is more electronegative and it is pulling the electrons more towards itself. The hydrogen will be partially positive because those electrons are being pulled away. So what ends up happening with these water molecules, since it is polar, is that it not only interacts with other molecules really interestingly, but it also interacts with itself in a fascinating way. What happens is that these water molecules end up being attracted to each other. One end of the water molecule has a negative charge. The other end has a positive charge. Opposite charges attract. So what we see is what is called hydrogen bonding, which is represented by these dashed lines here. The negative end, the oxygen end of a water molecule, is attracted to the positive hydrogen side of another water molecule. Again, forming these bonds, and I put them in air quotes because they're not traditional bonds, but these attractions that create a nice structure that the water being connected to itself. All right, so we would add our dotted lines between the oxygens and the hydrogen sides here. So this polarity and this hydrogen bonding is super important in water acting the way that it does. So when we go to the next assignment after this, the 11 assignment, where you're looking at the water properties, each property can be directly attributed to the fact that water is polar or the fact that water can hydrogen bond with itself. So keep that in mind. All right. So we are going to watch this video.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
All right, so that cool video kind of talked us through what we just went through, or what we just discussed about water being a polar molecule, and gave you a nice preview to show you how the polarity and hydrogen bonding result in some of these really cool properties that they discussed, like cohesion, adhesion, surface tension, as well as water being really good at dissolving stuff. So your assignment again is going to be going through the water properties lecture notes. You're going to copy them down on your piece of paper or on your Cornell notes that are in the assignment here. Again, the other two, you'll either use the slides to copy down your notes, or you'll view the Edpuzzle to copy down your notes on there. And so again, your Cornell notes look like this, and you'll be going through this whole assignment. There is a lot there, but you can do it. All right. So again, there's many ways that you can do this polarity lecture and notes. The big thing is that you turn in your finished Cornell notes when you are done. So that is the only assignment for this week having to do with this lesson. So what I'd like you guys to do is tell me 2 things that you learned from today's lesson or from that video that you didn't know before. Awesome, y'all. If you don't have any questions, you can hop off here, and I will see you next time. Bye.